In 5.5, we're going to continue to use a lot of synthetic division to do a couple things. We're going to use it in this case to prove that something is a root, and then to use that to help us find additional roots. So this is telling us that we have this polynomial. It's a pretty big polynomial, and it wants us to prove that -5 is a root. Now, the nice thing about this problem is you know what should happen at the end if you do it right, is you should get a 0 remainder. That's how I prove that something's a root. So I'm going to put my coefficients across the tops, 2, 7, -11. I don't need any placeholders, 21 and 5. And I'm going to prove that -5 is a root. So I'm going to drop the 2 down, multiply, add, multiply, add, multiply, add, multiply, add. And right here, that's the proof. The proof is actually just your final remainder. If you get a 0 remainder, you have successfully proven that it is a root. If you get anything that's not a 0 remainder, you're proving that it's not a root or a solution, or that you did something wrong and you need to go back and fix it. Look at something like this, same thing. It wants you to prove that -4 is a root. So we're going to put 1, 8, 4, and -48. Put -4 outside, drop down the 1, multiply, add, multiply, add, multiply, add. So again, this proves it. So let's take it a step further. Once we've proven that -4 is a solution or is a root, what if we want to find the other roots? Because we know with degree 3, we potentially could have up to 3 solutions. So if we want to find the rest, well, we're going to write down what's left. So we're going to take these coefficients and write down the polynomial that represents. It represents 1x squared plus 4 plus 4x minus 12. If I want to find the additional solutions, well, now I'm left with something that I can factor. I can factor this. I need 2 numbers that multiply to get -12 and add to get 4. So we still do a lot of factoring in this chapter, even at the end. So my factors are x plus 6 and x minus 2, which means my other solutions are -6 and +2. And the nice thing with this is the calculator will verify everything we just did. If we graph it, so we're going to graph x to the third plus 8x squared plus 4x minus 48. If we take a look at that graph, we're going to see 3 times where the graph goes through the x-axis, and I can even count on the axis where it crosses. So it does cross at -4, which was the given one, but it's also crossing the axis at +2 and at -6, were the ones that we found with factoring. So our picture matches our work. I'm not going to do this one. It's a little long. It's the same idea. I'm going to do this second one, the one on the right side, because I think it also can illustrate what I just talked about. Plus, it does need a placeholder. You'll notice there is no x squared. So we have 1x cubed, 0x squared, -19x's, and 30. And we're going to prove that -5 is one of the solutions or one of the roots. So we drop down the 1, multiply, add, multiply, add, multiply, add. And again, there's the proof. The proof is getting the 0 at the end. But if I wanted to go further and say, well, what are the other solutions? So we're going to write down what these numbers represent. They represent 1x squared minus 5x plus 6. If I want to figure out what makes that equal to 0, I can factor. So I need numbers that multiply to get 6 and add to get -5. That's -2 and -3. So we get x minus 2, x minus 3. So the other 2 solutions are 2 and 3. So it allows us to use the synthetic division to kind of get it simpler for us so that we're able to factor. So what if you're not given any starting value? So a lot of times, you notice the ones that we just did, I gave you a number and said, here's one that I know for sure is a solution. You prove it using things synthetic and then continue from there. So what if you're only given a function? Well, the nice thing is, prior to the age of graphing calculators, you had to do a lot of guesswork and a lot of trying a lot of solutions, and it took a really long time. But graphing calculators have really streamlined the work. So if you have something like this, you're going to graph it on your calculator first to get that starting picture. So we're going to put in x to the third, and then plus 3x squared, minus 13x, and minus 15. And we're going to graph that. And I'm going to try to stick with everything on a basic window. So you'll notice I just hit graph. If your calculator window's acting a little goofy, if you hit zoom and 6, it'll put it back to a standard window. So I can tell from my picture that it looks like it's going through the x-axis at 3, at -1, and at -5. So I can tell just from my picture where I believe that the solutions are. I can prove it by doing synthetic division. I can prove it by factoring. So I'm going to start with my synthetic division. So 1, 3, -13, and -15. And the first one, I'm going to go with 3. I like working with positive numbers, and 3 is one of my favorites. So I'm going to put a 3 here. It does not matter which number you choose first. If you can look at the picture and have a good idea of where it crosses. Sometimes it's tough to see one, so go with the one that's easiest to see. So drop down, multiply, add, multiply, add, multiply, add. Now you have a decision to make. You can do synthetic again, and I do want to show you that, or you can factor. Let me show you what it would look like to do synthetic again, just because we just did some factoring. I want to show you another option. So if I look at my picture, what I believe in my picture is that it also crosses at -1. So I am allowed to actually do another synthetic division. I don't have to start over with the values that remained when I did it the first time. I'm going to put the next 0 out there. I'm going to drop down, I'm going to multiply, I'm going to add, multiply, and add. And again, since I got 0 here, I have proven that -1 was also a solution. At this point, I can do it again if I would like. Or I can look at this and say, all right, I did division twice. I started off with an x to the third. Every time I divide, it drops that power 1 down 1. So if I've divided twice, this 1 represents a 1x, and this 5 represents just a +5. And if I want to know what makes that equal to 0, well, that is just -5. Or I could have done synthetic division again. I actually have a lot of options as we get towards the end of this chapter, because now I have a bigger skill set. I have synthetic division, I have long division, I have factoring. All of those things will lead me to my answers. Let me show you another one just so you can kind of see how this looks. So again, I have no gimmies. What I mean by that is I have no saying, well, here's an answer I know will work. You have to be relying on the picture. You can graph it on your calculator. You can graph it on Desmos, whatever you're comfortable with. So x to the third minus 3x to the second minus 10x plus 24. And I'm going to graph it. And it looks like it crosses at -3, it looks like it crosses at 2, and it looks like it crosses at 4. And I get to pick, because all of those are pretty clear to see, which one of those ones I want to start with. So I'm going to start with 2. It's a positive number, it's small, so I've got 1, -3, -10, and 24. I'm going to start with 2. Now, if you go through this process and it doesn't work, if you don't get a 0 remainder, what that's telling you is either something went wrong with your arithmetic, or maybe you weren't reading your picture right, or maybe you graphed it wrong. So double check what you entered in your calculator. So this one works out perfectly. We again get a 0 remainder. At this point, I can do synthetic again, or just give you your options. I can write down what's left. So I'm left with x squared minus 1x minus 12. And that actually factors. I need numbers that multiply get -12 and add to get -1. So that's -4 and 3. So it factors to x minus 4, x plus 3. So my solutions are the 2 that I found up here when I did synthetic, 4 from this factor, and -3 from this factor. So I'm kind of combining skill sets to be able to prove all the places that I see on the calculator where it equals 0. This is the last one I'm going to do, just to kind of show you one more. I can actually do this one in a totally different way. So I'm going to try to show you all the variety that you could see. Let me graph it on your calculator first. So I've got x to the third plus 4x squared minus 9x minus 36, and I'm going to hit graph. And what you'll notice is it looks like it crosses at 3, it looks like it crosses at -3, and it looks like it crosses at -4. Again, we can do synthetic division the whole time. And I've had students that just like the synthetic division process. It's very consistent, and they'll do it nonstop. I've also had students that really prefer factoring and will kind of gravitate towards that. This one you could actually do either way. I'm going to show you the factoring way just to show you something different. This one has 4 terms. The only way to factor something with 4 terms is to group it up, and this one actually groups really nicely. You can take an x squared out of the first 2 terms, and you're left with x plus 4. And then you can take a -9 out of the next 2 terms, and you're also left with an x plus 4. pull the x plus 4 out front. You're left with x squared minus 9, which hopefully you recognize does factor more. It is a difference of squares. It factors x plus 3, x minus 3. And with this, I get my 3 solutions that I saw on my calculator, -4, -3, and +3. So that is one way to do the problem. The other option, and you definitely don't have to do both, just showing you options, is to set up a synthetic division with any of those numbers. So I'm going to start with 3. I told you I like that number. So drop down, multiply, add, 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 and say, okay, well, that one worked because I got a 0 remainder. So now let's try -3. So drop down, multiply, add. Again, that proved it. I got another 0 remainder. And I could even do it with my other one I saw, -4, drop down, multiply, add. So those are 2 completely different ways to prove the same 3 solutions, all stemming from what I saw on the picture when I graphed it. So that's kind of where 5.5 is heading. It's going to take your factoring skills. It's going to take your synthetic skills and your graphing calculator to be able to find all of the zeros in different ways.